All right, folks, we can get started. Let me just prep my environment here real quick. Let's clean this up from last time. Let's put this at the top. Good. All right, cool. As usual, feel free to bring me any questions related to Python, and I'll get to them as soon as I can. That is the primary purpose of study halls, so feel free to do that. Pop those in the Slack thread under the message that I sent in the basic prep channel, and include a link to the problem in if it's in Learn, or I'm also willing to go through Code Wars problems as well, if they're small enough to be bite size for the sake of getting through them in the time that we have allotted. So feel free to just pop in the link there and give me a short description, if you can, of like, you know, how you're approaching it or what you're thinking about. Just even a couple words or two, like trying to do this, and that can help me answer your question in a way that's suited to the way you're working through it. Also, if you just want me to go through it and be like, you know, can you solve this on stream, I'm willing to do that too. Let's see, just trying to adjust this a little bit. Okay, there we go. Yeah, cool. So pop in the links and I'll go through your questions as they come up. If I'm not getting any questions, which we don't have any questions currently, then I'm just going to go through the premium prep material here, or the basic prep material actually. All right, we've got, looks like we got to unpacking a list. Now, I want to do a quick touch on what we covered last time. Mutability and modifying. This is, I know this can seem kind of like a side topic, but it becomes sort of a central idea in a lot of programming, or it can kind of take, it can be important in a way that may not be totally obvious. So let's just take another quick look at mutability. I'm not going to go into a huge discussion on this because we've talked about this recently in several other study halls as well as in premium prep, but we'll just go over this real quickly. So mutability means that you have an object or a data type, one of the data types, that has the ability to change its own value. Kind of, it has features that allow it to change its value. This is different than when you change the value of a variable, right? So if I have this, like, my variable equals a number, and then down here I have my variable equals another number. This is not mutation, right? Like, what a variable is, the way it works, it's a pointer. It's just an identifier in your program's memory that gets stored in your program's memory, and it has a essentially it points to a address in your computer's RAM where this data can be found. When I make this assignment, all of the details for implementing and brokering that get done automatically. when I say equals, right? So when I say var equals 6, it creates an identifier called var, and that identifier holds a pointer to the value 6 in your computer's memory. And then if I, down here, if I say var equals 5, well, it finds that var variable, and then it just swaps out its pointer. It's the same identifier, right? Var is the same identifier, but it swaps out the pointer to point at a different integer, right? So what happened here in these cases are the pointer inside the variable identifier changed to point to a new object, right? So the pointer changed, not the object. Something is mutable when the object changes but the pointer doesn't. Okay, so let's just look at that really quick. There's a handy dandy little tool for this. We can print the ID of var, and actually let's print it, let's print it when var is equal to 6, and then when var is equal to 5. And if the IDs are the same, then we know that the object is the same, meaning it's the pointer didn't change, the object changed, right? If the IDs are different, we know it's a different object, so type object. And I hope that's clear the way I'm using the word object. Object in this case is a synonym to data type. When I'm saying object, I'm referring to an int or a float or a string or one of the things that you would think of as a data type that we've talked about as data types. Okay, cool. So we can see the ID here is different, meaning that 6 is a different object. It's a different integer object than 5. Since the IDs are different, we can make that assertion that the objects themselves are different. But so in this case, we reassigned the pointer to point at a different object rather than changing the object itself. And to be clear, integers are immutable. There's no way to change the 6 to a 5 other than to just have a variable and point it to a different object. Okay, so let's do this. List equals list of, let's just do 1, 2, 3. And then we'll say print ID of this list. I should probably comment these out. Well, we'll just look down here. So the idea of this list is, you can see it's kind of a different ID format, evidently. It uses, my interpreter is using a slightly different format for the IDs of more complicated objects like lists, I guess. Just so we can see the identifier there. Let's, or the ID. Okay, we'll just comment that out. So there are several ways we can, several aspects of this list equals list that we can change. Generally, when you have a list, quite often when you have a list, here, I'll just comment that out for now. You start with an empty list, and you do like an accumulator pattern for I in range 10 list.append. We're going to append to the list. This is a common way of altering a list, is appending to it. And append is a mutable method. It changes the list itself. So we'll list.append, we'll just say I squared. And cool. So let's print the ID when the empty list is initially created, and then again after we've appended to it. Okay, you can see the ID did not change, so that means we didn't tell the identifier to point at a different object. It's still pointing at the same object. It's just that this object was an empty list, and now it has contents, right? Let's just prove that. List. Yeah, we'll just print out the value of list there, and we'll print out the value of list there. Cool. Okay, so you can see we have ID and then value and then ID and then value. So if we look at the IDs, they are obviously the same. If we look at the values, they are obviously not the same. One is an empty list and one has stuff in it, right? So yeah. So even though the value changed, it's still the same list. We've just modified that existing list. So that's essentially the idea of mutability, is that the object, being the list in this case, can change rather than needing to point the variable at a new object. Cool. Let's just label this. Good. All right, unpacking lists. So the goal of this is to be able to unpack short lists. So unpacking, sometimes this is called multiple variable assignment, where you can assign multiple variables on one line. When you're unpacking, the thing that you're unpacking, in this case we're unpacking a list, we could also unpack tuples. But whatever you're unpacking has to be of a certain length, right? So in this case we're unpacking three. I just realized this is a South Park reference. Man, bear, pig. Okay, that's funny. Whatever we're unpacking, we only get to write in like a specific amount of things, right? So if we unwrite, or if we unpack 3 things, there better be 3 things in the list, no less and no more. Otherwise, you know, you can ask yourself, what assumption should Python make? And to me, the answer is that there isn't a clear assumption to be made. So let me just give an example of this. So let's say I have my list. We'll just do this. I'll type it out. Sum list equals a list of man, bear, pig. And you know, if I print the list, obviously, well, I don't even need to do that. So let's do this. Element 1 equal, or element 1, element 2, element 3 equals sum list. So if I print element 2, I'm going to get bear. Right, and the same thing would work if I just had this as well. We can skip this sum list variable step if we wanted to. This would work. The same thing would also work if we had def return def man, bear, pig, and we'll just return this list like this, straight up. And then if we call man, bear, pig, so we have a function, it returns a list with 3 elements. We unpack each of the 3 elements into their own variable names, and we print out the element, whichever element we want. So we could do cool. All right, so what I was saying before is, and I'm just going to do this, I'm just going to kind of simplify this example here. We'll just do it straight across like this, so there's less to look at. Okay. So if I add a yak to this, so now we're unpacking 3 elements from this list of 4 elements, right? So we run this. We're actually going to get an error, right? This is going to say value error, too many values to unpack, expected 3, right? So the length matters here. And to my knowledge, I won't claim 100% knowledge on this particular thing. You could go look it up, but to my knowledge, there isn't a way around this. I've never needed one either. So if you have a problem where you're like, I'm going to unpack the elements of a list into different variables, you better ask yourself, can I guarantee that I know the length of that list? Is it 100% guarantee that I can always guarantee a list of a certain length or a tuple of a certain length? Because the same thing will work with tuples. So that's just something to remember as you unpack lists and tuples. The length has to be the same as what you have here. Conversely, we'll get, I think, exactly the same error. Let's just copy that. Oh, it's slightly different. That makes sense. So if we have, let's actually, I'll give these in separate examples. So if I try to unpack 4 elements into 3 variables, I'm going to get this value error, and it's going to say too many values to unpack. If I tried to unpack 2 elements into 3 variables, it's going to say value error, not enough values to unpack, expected 3 got 2. It's interesting that this one doesn't say expected 3 got 4. But whatever. Same diff. Oops. Scroll down. Don't need to do that. So it's important to remember to unpack the correct amount of values. Cool. I will say I don't tend to unpack a lot of lists. Part of the reason is actually what I just covered up here, right? Like, lists are mutable. Yeah, you might be thinking about this, or this thought may have occurred to you, right? Like, I just said this thing about lists themselves being able to change, right? Specifically, not only the values inside them, but specifically change in size. They can grow, they can shrink, they can be cleared. There's various size changes that can affect lists. So to me, I don't tend to unpack lists that much because often I can't guarantee that the list will remain the size that I need it to remain for the unpack. So what I tend to do is, if I think I need to unpack a list, I'll often say, we'll have our list equals, let's just say it equals man, bear, pig, and then I might say tup equals tuple of list. And then I might try to unpack the tup rather than the list, because I can guarantee the size of a tuple. Or if the variable, the identifier pointing with the pointer to the tuple, if that changes, it's because I changed it. Like I am definitely the author of that change. It's not like some other piece of code can come along and cause a mutation to my tuple behind the scenes without me knowing, which can sometimes be the case with lists. And that may be desirable behavior, is that mutability, that extreme flexibility of lists, but also the simplicity and sort of robust predictability of tuples can be desirable as well. So just a little thought there. Let's see, I'm going to put this down here. And just comment that out. That'll do. All right. So that's unpacking in a nutshell. Let's just jump in and do the challenges. Okay. I think I just gave this example. Oops. There we go. All right, so unpack a list challenge. Write a function called list unpacker. This function takes one parameter, a list of length 3 as an argument. Takes one unpacker, or one parameter, which is a list of length 3. So notice we have to have that fixed length. The function should return the 3 values from the list in the order found in the list. Okay. So the funny thing is, if we return them like this, we're going to end up with a tuple. So I bet I could hack this one in an interesting way. We'll get to that in a second. I'm just going to go forward with a solve. I'm not going to even read the rest of this. If I'm wrong, I'm wrong, and I'll come back and read it. So this one wanted to be called what? What was it? List unpacker. Def list unpacker takes in a list and will return L1, L2, L3. Now I just do the return first because I tend to write in my return first. Makes it clear like where I'm heading and like what I'm building up to. It just is sort of a habit. So obviously these 3 don't exist yet, so we'll just make them exist. L1, L2, L3 equal list, and we'll just submit this, see if it's going to work here. I think it will. Cool. Pretty sure if I just return like this, I think that's going to give us the same thing. Yeah. Yeah, this will trick the tests into thinking we got the right result. But yeah, without doing the unpacking. So that's the cheating way of doing it. Obviously don't do it the cheating way, but also do it the cheating way after you do the non-cheating way, because it's good to explore and it's fun. Cool. All right. What will the Python interpreter do if you try to unpack a list that contains 3 objects in 4 variables? It sets the 4th variable to none. Nope. It throws an exception and halts the execution of the code. it assigns the first 3 variables and ignores the fourth. Nope. It's going to throw an exception. Exception is kind of another word for an error. Probably obvious, but synonyms. Did I do this one? No. Good. All right. In the code below, you are given a list containing 4 elements. Unpack the list as follows. The first element should be stored in the variable we. The second are unpacking. Okay, so I'm going to do this. Whoops, can I do that? Huh. All right. I'm so determined to do it my way. I'll just copy you over to the text editor. Fine then. Browser. We are unpacking our list. And we'll do this. Commas equals, what was this called? List? Oh, that's what I call it. List. There we go. That should do it. Okay. Hopefully that's clear what's going on there. We have list. This list needs unpacking, and then we, comma, our, comma, unpacking, comma, our list equals list. Excellent. Not seeing any anything going on in the chat, so I'm assuming that everybody's comprehension of the material is completely perfect, and that my teaching is also perfect, because that's what I'm just going to imagine left to my own devices. So yeah, how about that? No, but seriously, if you have questions, put them in the chat. I mean, questions about other Python questions that you might be stuck on, but also just questions about the material that I'm going through is totally fine. It's absolutely, this is absolutely the place for you to be confused if you're confused. Cool. Now let's just comment this out. All right. The append method. We were just talking about this with lists. So our objective is to append new elements to the list. I kind of don't think well, I'll give a quick example of it. Okay, so we have our list. We'll just call it our list. Start it with an empty list. If I print off the value, no surprises here. We're going to get an empty list. If I our list dot append hello world, we're going to get a list with hello world added into it. And if I print off another list, hello there. So we can append to this again. Okay, so we have a request to look at some statistics coding problems. We could I'm thinking we could just go through, yeah. Do you have a particular question in mind? Probability? Okay. Oops, I'm looking at the wrong thing. No wonder. Intro to stats. Okay. I'll just jump in somewhere here in permutations. Yeah, sorry. If you have, I'm kind of just struggling to like jump into something specific. If you have something specific, would you just send that in? Cool. Thank you. All right, I'm just gonna go through. We'll just do this append one, and I'll check back in, see where you're at. Cool. All right, so I think I gave a good, I think this is a good simple example of what append does. You can see we're just adding things into the list every time we call append. So we call append on the list that we want to append to, and then we pass it, like a function, we pass it the thing that we want to be appended to that list. Okay. Okay, so let's look at this first challenge. In the code cell below, list is declared as a list with 4 integers in it. Append any object to the end of the first list and submit your code. Okay, list dot append height. All right. So what will be the value of the list after the following commands? So we initialize our list, and then we append this other list to it. So we're actually appending one item. So this is an important feature of append. Append can only append one thing, so it's not going to append all of these things to the list. This is one list that's being appended to the original list, right? So we're going to have a nested list after we're done with this. So we should have a list with a list in it, and I see this is one list, this is a list with a list in it, and this is a tuple with 2 lists in it, so that'll be a list with a list. Good. Okay. Append method challenge. So write a function called append 3 elements. This function takes in 4 arguments as parameters. Let's see. The first argument, oh, it wants specific names for them. The first argument is a list called list that you will be appending to. The next 3 parameters will be objects that need to be added to the list, A, B, and C. Okay, Cool. We'll just def, and we can, boom. So I think I'll just say list.append A, copy that, B and C, and I think, do we need to return? Okay, it does say to return list. We'll do that. It's actually kind of interesting behavior. You would normally not do this, to be clear. Let me show you why. I'll have my list equals a list with 1, 2, 3, and then we'll say append 3 elements, and we'll take in my list, and we'll append a B, C, like this. So we should get 1, 2, 3, ABC. So if I run the code, it's going to return something. It's going to return our list. But actually, if I examine my list, you might think, what would the value of my list be? So my list has actually changed with this code, which is generally not behavior you want. Specifically the behavior that you don't want is you don't want to write a function that modifies one of its inputs. This function modifies one of its inputs. That's what's being asked here in learn. So I think that's essential. Let me just try to do it without it. List equals list.copy. We'll just try that and see if it'll work with a copied version. But I presume, by the way they said it, well, that'll work too. Oh, actually, that's the example that they give as well. I should have looked at that. Yeah, so you could do this in 2 ways, but the better way to do it is to copy the list. So list equals list.copy. That way we're altering a copy of the input, which is fine. This copy lives locally inside of this function, and then we return it. That's fine. I'm not mutating my data from the outside world. I'm leaving that alone, and I'm getting a copy of it and returning that copy. So if I run this code again, look at my list, we'll see that my list did not change. Cool. All right. Good. All right, we have an update on the request for stats questions. So welcome to probability and statistics section. Let's see. Challenge 4. Placement challenge, presumably the placement challenge. I'm guessing that's this. Just determine the best measure of central tendency for the collection below. You were asking for coding questions. This doesn't seem like, for my guess, this doesn't seem like what you were asking. Is this the right question? Okay, I'm assuming that's a yes. Determine the best measure of central tendency. Oh, I see what you mean. We could code this out. I don't know what's wrong with me today. I didn't sleep. exceptionally well. Actually, I slept exceptionally poorly. I feel fine, but I think I'm like my brain is kind of a little off. One of those nights. Okay. So let's do this. So what would be the best measure of centers? So I would just say let's just code out mean, median, and mode. So our mean is going to be our average. Our median is going to be our middleist value. I'm splitting hairs over how to spell middleist, which is not a word, but I'm using it anyways. And then our mode is going to be our most common value, the value that occurred the most often. Actually, number 32. Okay. Number 32. Sorry. Question 32. Sorry. Okay, challenge 4. Let the random variable x represent the duration. Okay. Let's do this one. Sorry about getting off on that one. Cool. Let's do this. We'll see if I can solve this within the time we have left. Cool. So let the random variable x represent the duration of rainfall at the Toronto International Airport. Let the random variable x represent the duration of rainfall at the Toronto International Airport. Okay. The random variable was found to follow an exponential distribution with a mean of 2.725 hours according to the journal. Urban stormwater management planning, da-da-da. Just delete that. The random variable was found to follow an exponential distribution with a mean of 2.725 hours. Okay. What is the probability that the randomly chosen rainstorm will last more than 4 hours? So I assume we need to build an exponential distribution function for this, which is not something. I'm gonna have to consult this. I have to look this up. To be clear, the placement challenges, these are to give you an idea of how where you should start in the material, not necessarily they're not necessarily meant to be all solved. So let's just go through this though. Introduction to stats. So we want to do continuous probability of distributions. Let's see if we can find exponential. Okay. me just get a formula. If I can find a formula, I can implement the formula. Okay. So the PDF for the exponential is going to be lambda e to the negative lambda x. Okay. Yeah, I'm going to have to push this one off onto Tovio. I'm sorry. I don't think I can help you with this in stream, unfortunately. That's embarrassing. Yeah. Apologies for that. I will DM Tovio, though, if you want me to let them know that you're wanting help with that particular problem. Cool. I'm just going to jump back into manipulating lists for now. Yeah, sure thing. Yeah, sorry about that. I am so much more a programmer first than I am a statistician. That stuff is still, frankly, things that I'm still learning, part of my own education. But I can help with the discrete distributions for sure. But yeah. Anyways, all right. Let's just jump into the extend method here. Cool. So we're going to use extend to extend a list. Extend is a lot like append. The difference is that you can add in multiple things at once. Let's just do this. All right. So so let's juxtapose it against append real quick. We'll just say list equals, we'll have an empty list. And let's say I have a number of things that I want to add into the list. Let's say I'll have another list, other list equals, let's say, cool. Okay, so let's say I want to add all of these elements into my sum. We'll just call this sum list. Well, I could create a for loop and say for L in other list. Sum list dot append L, but it's kind of a lot of hassle to go through several steps involved to just get the contents of this other list in sum list. So we can shortcut that whole thing by just saying sum list dot extend other list. So we're extending sum list with other list. So the object being altered here is going to be sum list. And let's actually put some things in sum list. Let's just do A, B, whoops, C, D. Okay, cool. So there's our sum list. Let's see what happened to other list. Cool. So our other list stayed the same, notice. So the list that's being altered is the list that we're calling the method on, which is always going to be the case, but just in case there's any confusion about that. Cool. Yeah, we could just march through this. So if you have two lists and wanted to combine them into one longer list, extend, since, yeah. Extend method challenge. Let's just try this out. Okay, in the code block below, complete the following. In a variable called numList, let's do this. Okay. Create a list that contains the values 0 through 9 inclusive. Okay. So we'll say numList and string list. We'll say equals, these are both lists. Actually, I'm just going to do list range 9 plus 1. Of course, that's 10. We'll just do 10. So we'll just take a range of 10, convert it to a list, and our string list is going to be, this is a test, presumably. Okay, so extend numList so it also contains the values 100 through 109. Okay. So numList dot extend. And we'll do list range 100 109. Actually, this would be 110. And then we'll extend the other one, LIST. I have to actually spell this correctly. Number list. Okay. And string list. And then we'll extend string list with a list of these. Number list is not defined. Okay. Ah, there we go. Typo. Okay, cool. So let's just print those out. Good. Looks good to me. Okay, cool. So next one, write a function called da da da. We'll just go straight on to the next one. Write a function called extend lists. This function takes 3 lists as arguments. This function should return a new list containing all the elements of the 3 passed in lists. Okay, so we'll just say L1, L2, L3, and I'm just going to say LST equals an empty list, and we're just going to LST dot extend L1 plus L2 plus L3 return list. Let me actually read the rest of this. This function should take in 3 lists. Function should return a new list containing all the elements of the 3 passed in lists. These elements should be in order of the lists as they were passed in, so list 1, 2, 3, good. You can assume that there is no nested list, for example. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9 should return this. So let's just take this test. Cool. Let's see if that works. 1, 2, 3, 4, 5, 6, 7, 8, 9. Good. Funny thing about this, though, we could just return the thing that we're extending, and it'll be fine. Yeah, I'm actually going to submit it that way. This is kind of preferable since we're returning a new list. When you make a concatenation of any list, it's gonna see this as a different object. It's not going to assume that it's any of these objects that is the concatenated version. So this actually returns a new object anyway, so that should work. Of course, we'll see. And it does. Cool. So they're just doing 3 extends here. List 1, 2, 3 equals empty list, and then extend list 1, extend list 2, extend list 3. This is it's fine to approach it that way as well. Cool. Removing items from a list. So that by the end of this, we'll be removing items using the remove method and the del method. Well, the del approach. Cool. Let's just look at let's just take a list here. Actually, well, we'll start over. So let's say I have animals list. We'll have dog, cat, bird, mouse. Okay. Animals. Print that off. Not surprising there. So let's try to delete some of these strategically. Let's have a duplicate in here too, because that can be interesting. So let's do cat again. Okay, so dog, cat, bird, cat, mouse. So let's use the .remove method, and we'll say animals .remove, and then we'll specify an element. So we'll say cat. So notice I asked it to remove cat, and it found the element that matched cat, and it removed it. It only removed the first instance, though, right? Let's just... Oh, they're going with del first. Where is the remove method? Okay, oh, it's just this little example, yeah. So, remove is only going to remove the first element. If you want to remove both, if you want to remove multiples, you have to call remove for as many times as there are that element in the list. So notice if I try to remove an element that is not in the list, it's going to say list.remove x. X is not in list. This is going to be a value error. So remove has to whatever we pass to remove has to be in the list to be removed. So a lot of times if you have something in a list and you want to remove all of them, but you don't know how many of it you have in the list, you can say for I in range animals dot count, and we'll just say target and I'll say target equals cat. So our target is our target thing to remove, whatever element that we want to remove. Okay. So I don't think we need I, actually. We'll just say underscore, just to say we're not going to use it. So what this does, we have animals.count target. Target is equal to cat, so this is animals.count cat. So .count is going to give us the number, it's going to return an integer that represents the number of times that target occurred in animals, right? That our argument occurred in our list, right? So in this case, cat occurs twice, so animals.count target or animals.count cat is going to return 2. And we're passing that 2, notice that 2 is going to evaluate here inside of range. So this is going to be for blank in range 2, which means we're going to have a list that iterates twice, right? And then I'm just going to call animals.remove target in there, and now it's going to call it as many times as count of the target, right? So it's a little convoluted, but this is a useful pattern to remember that you can sort of match up remove and count in a for loop and remove all of the elements of a given target, whatever you're trying to remove. Cool. So let's look at the other way. We'll just leave the cats out of there for now. Let's say I want to remove actually we'll reinitialize it. We'll do this. Okay, so we have our oops. Oops, there we go. Clean it up a little. We have our list. And now let's use del. So del works quite a bit differently. Notice how when I type out del, it highlights in this sort of pink purple, which in my highlighting scheme is the color used for operators and keywords. So the equal, the for, the in, if we type in def, those kinds of things. So del is something that is built into Python. It is a built-in keyword. And we can say del animals sub, and now we'll give it an index. So if I want to delete something at a certain index, let's say I want to delete the element at index 0, 1, 2. So we'll delete bird, and then if I print animals, we should see dog, cat, cat, mouse. Cool, because I removed that bird. I could also delete the entire list. And then when I print animals, it's actually going to give me a name error. So it not only did it clean up the list value, but it also cleaned up the identifier. We end up with an orphaned identifier, and Python automatically knows that, well, since we have an identifier that's not pointing at anything that exists, then we'll just delete it. So it deletes it. Cool. All right. Let's look at the challenges. What's the proper combination of ways to remove the fish item from the following list? Cat, dog, frog, kitten, fish. So that's 0, 1, 2, 3, 4. So we could say remove -3. Nope. 0, 1, 2, or -1, -2, -3. So that's going to be, this is either index 4 or index -3. So del list sub -3 is correct, and list.remove fish would also do it. So both of those would do it. Cool. Write a function called remove if in list that takes 2 arguments. The first argument is a list and the second argument is the element to be removed. Cool. Or actually, here I want to copy that in. Well, I want to copy the whole thing in. What am I doing? Come over to my text editor here. Let's take this test out. Okay. So, I'm curious about this one. I can think of a couple ways to do it. So, I'm assuming that they want us to modify the initial list, although maybe not. Maybe they just want us to return it. Let's see. The first argument is the list. The second argument is the element to be removed. The function should return a list with the element removed. Note, the element may not be in the list. So first you need to check to see if the element is. If it is in the list, then remove the element. What about if it's not? Doesn't tell us. Okay, whatever. I should go in and edit that copy to be explicit about what we do if it's not in the list. Presumably we'll just return none. Since it's not specifying anything, won't do anything. So I'll say if obj to remove in list, then we'll say list dot remove obj to remove. So cat, dog, fish, bird. If we want to remove bird, should give us cat, dog, fish. Yeah, we're not returning anything, so we're not going to see anything interesting happen there. But let's just submit it, see what happens. It's not going to work. Okay. Let's just return list. Okay, that's what it wanted. It did want us to return. Run a function takes 2 arguments. The first is the element. The function should, oh, I just totally missed this. The function should return a list with the elements removed. Okay, cool. That's obvious now. All right, write a function called element at 0, or remove element at 0 that takes a list as an argument. This function should return the list with the first element removed. Okay. So this will be def takes in a list, and this will del list sub 0 and return list. Good. All right, on to the next one. More list functions and methods. Okay, so by the end of this lesson, we want you to know how to use the len and the sum functions, sorted, reverse, min and max, any and all, pop, sort, and reverse. Yeah, I tend to favor sorted and reversed over the sort and reversed methods. These tend to be preferable, but it's just me. We'll get into that. Cool. So functions versus methods. I've talked about this a little bit in Premium Prep. We did get into this when we went over the object-oriented programming lesson just recently. So a method is like a method lives as a property of the data type that it bears on. So append is a method, right? List.append. Append doesn't exist as an independent entity outside of a list. It's like a built-in feature of a list, right? Count also, right? Now you may notice tuples have count, and I think strings also have count. But still, in all of these cases, these methods are implemented for each of these types specifically and exclusively, right? They have the same name, but they do the same thing, but they're bound to those types themselves, right? A function lives independently of an object. A function is its own standalone entity. The difference is, like, the meaningful difference between the two, I would say, is more in convention of how they're used. which is functions don't modify their inputs by convention. Python allows you to write functions that modify their inputs. We saw that at the beginning today when we looked at mutability. Python will allow you to write functions that modify the inputs of that function. So if it takes in a list, it could potentially modify that list. But that's not how you're supposed to use functions. If you're writing methods, methods are sort of canonically allowed to alter the type that they're called on. But also, if we had a method, I don't know, list dot some method, we'll say some mutable method, this mutable method might be allowed to alter the list that it's called on, but still you wouldn't want it to, let's say it took in other list, some other list, some other mutable type. We wouldn't want it to alter its inputs, right? So the thing is with methods, the methods may or may not alter the input. Functions should never alter their inputs. Although methods may or may not alter the type that they're called on. Some methods don't. Some methods like count, for instance, count behaves very much like a function, very much like any function. It just, you call it on a thing that has something that it can count, and you pass it something to count, and it returns the count, returns an integer representing the count of that object in the collection, right? You might wonder why they didn't have a function called count that takes in an iterable and something to count. I don't know, something to count. Like this totally could exist. You could write count as a function and it would be fine. It would totally make sense. But the developers of Python chose to implement count as a method, and that's just a sort of a trivial stylistic decision in this case, right? So to be clear, in terms of what functions and methods are capable of, they're basically capable of the same set of things. Mostly, they both are able to mutate their inputs. They both are able to return values, although by convention, functions must never mutate their inputs, and probably should always have a return. And by convention, methods are allowed to mutate the objects that they're a part of, and or they're allowed to return. Some methods do both, right? Like pop does both. So if I say list equals B, C, and then let's say I want to pop a certain index, I can say element equals list.pop, and then now I have to give pop an index. This is a lot like del in a way. So it's a lot like del because it takes an index and it removes the item at that index, which causes a mutation to the list, but it also returns that item. So if I say list.pop 1, so B is index 1, if I print L, L will be the element popped, which will be B. And if I print list, we'll see it was also altered. So methods may alter the types that they're part of, and or return something. In the case of pop, that it does both. Cool. All right, so that's sort of the rundown of the sort of use case differences for methods and functions. So this says a function is a sequence of instructions that performs a specific task. Functions are a basic construct of abstraction and allow for more granular processes to be easily reproducible. In other words, by identifying a function in a snippet of code, one can utilize that process over and over again by calling the function by name. Functions often take in some data as an input, perform some operation using those inputs, when defining a function, the names used to represent passed in data are referred to as parameters. That's true actually with methods as well. When actually using or calling the function, the data passed in is referred to as arguments. This is the correct definition. The practical definition is that whether we're defining or calling, invoking the function, we often just refer to the inputs as arguments. That's a very, very common thing to do. So often you'll hear me say arguments when technically I might mean parameters, but that's just a way of using that word that everybody does. So you would be understood if you just call it arguments. Cool. So to see a list of Python built-in functions, go here, Okay. Syntax. All right, looks like we got a question. We got about 5 minutes left in stream, but we'll just see what this is about real quick, see if I can answer this. Oh, okay. So this is the pop method. I'm taking it. Is this the pop challenge? Okay. Okay, cool. So let's see what this is all about. Okay, It is common in mathematics to remove outliers from the data set. The pop method, in conjunction with the .index method, can be a useful combination for accomplishing this task. I think I see we're gonna pop the index of the min of the list and pop the index of the max of the list. That's my guess. Complete the remove outliers function below. This function takes one parameter called data, okay, and is a collection of observed data. This function should return the data list with the smallest value removed and the largest value removed. Okay, cool. So let's do this. Okay, so we have to remove, actually I'll come back to this. We have to remove the largest element and the smallest element. So the first question is, how do we acquire those? How do we find and determine what the largest and what the smallest element is? So the min and max functions are going to be useful for this. So we can say, let's just print min. Give me 1 second. Sorry, folks. I think somebody's just knocking on my door here. Okay. Let's see here. Oh no. Are we back? Do I have sound? Okay. Sorry about that. Apologies. All right, so we just want to isolate the min and max. So we'll do min data and max data. Print those out just to verify that we're going to see those. Always a good idea to just print things out. So here we can see we have 1 as our min and 523 is our max. So whatever I get back, it better not have 1 or 523 in it, right? So let's just comment that out, keep that there for now. We'll come back and delete our comments when we're done. Okay. So now what I want to do is I want to print out. So I want to pop out these elements, but in order to pop, data.pop, I have to feed pop an index, right? So what I want is the index in data of the min of the data and the max of the data. And then we're going to return data. And I think I want to do, oops, I didn't even write return. Return. And then I think I want to do, I want to copy data, so I'll say data equals data.copy. Okay. See what this does. So I better get according to this, we expect 55, 23, 68, 81, and 99. I have 55, 23, 68, 81, and 99. Good. Let's see if that's going to work. Oh, did that? Oh, that was called data list. Let's just rectify that just to make sure. Okay, one more go. Yep. Data is not defined. There we go. Missed one. Perfect. All right, cool. All right, it's getting about time to where we'd normally wrap up stream. I will, to the original question asker, I'll look at the code that you have and see if there's like a disparity between the way I'm approaching this and what you're doing. I do notice I don't see a return in your code, and I think that's, if you're having a problem getting it to work, let's try to take out that return. I think that's going to break it, yeah. So this function is expecting a return. I hope it says that. Some of them, I think, don't say it, or it's not clear enough. Yeah, it does say it here. Sometimes it's kind of buried in there. And some of the functions don't want you to return something, so that's fair. So yeah, hope that helps. Sorry I couldn't get to that one question. I will ameliorate such shortcomings for future streams. I do apologize, and I will make sure to the person who asked that question that you do get an answer. Yeah, we'll get you the help you need for sure. Yeah. Feel free to DM me if you're on the Galvanize Slack channels. I'm always happy to help. I'm a little slow sometimes to get back on Slack, but I am available for one-on-one meetings and Python mentoring if anybody would like to do that. I have a lot of availability in my schedule over the next couple weeks, so feel free to DM me. Let me know what you like, what you didn't like. I'm always open to feedback and thoughts for improving these streams, because I want to make them as good as they can be. Cool. Yep. All right. That's it for today. I hope you all have a lovely rest of your evening, and I will see you on Monday. Bye-bye.